Alright guys, so we're going to go ahead and do this paper folding activity. So this is how you would do it. So you should have already tried this on your own. I'm just going to go through how to do it, so you can check your answers and make sure you're doing it right. So you want to have a piece of paper first of all. And so for part one, you're basically finding how many sections there are after a specific number of times you fold the paper. So if you fold your paper in half and determine the number of sections the paper has after you fold, that's what we're doing for each of the number of folds. So we're going to record the data in this table here. So as I get it, I'm going to type it in. So if I fold this, we talked about in the last video, if I fold this 0 times, then I will have 1 section in my paper. If I fold it twice, I'm going to fold this a little better than I did last time. So if I fold it twice and open it up, I'm going to have 2 sections. So if I fold it once, I'll open it up and I'll have 1 section. 2 sections. So if I fold it once, I'll have 2 sections. Now, if I fold it again, so that is 2 folds. So I get that. Then when I open it back up, I should have 1, 2, 3, 4 sections on my paper. So 4 sections. Alright, let's fold it one more time and hopefully we'll be able to see a pattern at this point. So there's 3 folds. So when I open it back up, I'm going to end up with 1, 2, 3, 4, 5, 6, 7, 8. 8 sections on the paper. Alright. In case you don't see the pattern yet, we'll do it one more again. So 4 folds. And so when I open this back up, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I will have 16 folds or sections of that paper. So hopefully you can see a pattern at that point. Alright, so hopefully you can see the pattern at this point. So if I folded 5 times, what's happening to these numbers over here is they're just doubling. So 1, if I double it, gives me 2. 2, if I double it, gives me 4. 4 gives me 8. 8 gives me 16. So 16 would give me 32. 6 folds would give me 64. And finally, 7 folds would give me, that would be 128. Alright, so then I have my data. So now, what is the input? Well, I'm going to type this. So the input is like what I would plug into a function and then that would give me a number out. So basically it's like what is independent or what stands on its own. So the input would be the number of folds because it doesn't depend on anything. I fold it and that's going to be the input. The output is going to be the number of sections that I would get out. Okay, so the number of folds gives me a number of sections. So the output is the number of sections. Alright, number 4, it says make a scatter plot on your data on your grid. We're just going to do that on the calculator. So we're going to take this data. You should have done this in Algebra 2. So we're going to take this data and plug it into our stat list. That's also going to allow us to find a model or an equation and make a scatter plot so we can see both of them on the same grid. So I'm going to go ahead and plug this data into my list. If there's already data there, you want to make sure you clear your list and not delete them. So I'm going to plug in 0, 1, 2, 3, 3, 4, 5, 6, 7. Alright, and then L2 is going to be 1, then 2, 4, 6, not 6, on a roll there, 2, 4, 8, 16, 32, 64, and 128. Alright, so here's our data. Now, if I want to make a scatter plot, what I'm going to do is go to my stat plot right up here. Okay, so I'm going to go to my stat plot and turn on plot 1. And so then I want my window to be a good fit around the data that I entered. And so if we go to Zoom Stat, it'll automatically fix us a really good window around our data. So you can tell that it's an exponential type function because it's got that same basic shape and it's getting really close to the x-axis down here. And so it's got that horizontal asymptote. So now we want to, so we've done number 4, we want to find an equation that represents the data. So we're just going to do an exponential regression and find our equation. So I'm going to go to Stat Calc, exponential reg, or xreg, and so I'm going to hit enter, and so then this is going to represent the model that gives me that data. So this is going to be y equals 1 times 2 raised to the x. So this is how I would write that, and I'm just going to type this in. So I'm going to insert, and apparently I'm not going to insert an equation because it won't let me do that right now. So I'm going to say y equals, and this would be 1 times 2, and I'm going to raise that to the x. So, whoa. So I'm going to, where's my little superscript? Right here. Raise that to the x. So that's my model. And so then, if I were to plug that into the calculator, y equals 1 times 2 to the x, and the 1 doesn't really change anything, so I could just type in 2 raised to the x. If I look at my graph, that should be a perfect fit going through all of those points. And it is. So there is my equation and my scatter plot. Alright, now for the next part, I'm not going to do this, but you should have done it with your ruler. So we're going to have the same number of folds, so I'm going to do 0, 1, 2, 3, 4, 5, 6, 7. And so the area of the section, remember I told you you would just have to, for 0 folds, you measure the length times the width, multiply those, and that would give you your area. So you should have gotten 93.5, and I was very exact with my measuring. So these are exact answers. So this should be 46.75, then 23.375, then 11.8675, 5.8438, and then 2.9219, 1.5469, and 0.7734. Alright, so then there are areas, and so like I said, I was very exact, and so I kept all of my decimals when I did that. And so if you did this, you should have started to see a pattern that evolved in this as well. And so the input on this is still going to be the number of folds. That's the one that doesn't depend on anything. The output on this is going to be the area of the section. And so we're going to make a scatter plot and determine a mathematical model the same way that we did on our last one. So I'm going to make my scatter plot by plugging in my data. So I'm going to go back to my lists and edit them. So I'm going to clear that one out. The list one stayed the same. So 93.5, 46.75. Y'all can fast forward this since I've already typed these in one place. 23.375. I am going to keep all of the decimals so it'll be as accurate as possible. And then 5.8438. And then 2.9219. And then 1.5469. And then 0.7734. Alright, so then there is our data. And so I'm going to go to stat. Actually, I'm going to graph this and find a good plot first. That's from the last one, so I'm going to clear that out. And then I'm going to go to zoom stat to put a good window around that. And so then here's our data. And so you can see this time that instead of increasing exponentially, going up, our data is decreasing. And that should make sense since our area of the smallest section is getting smaller as we make a fold. So here's our data. And now I want to find a model that represents that. So I want to determine a mathematical model. So I'm going to go to Stat Calc, same thing, exponential regression. Enter, enter. And so then here is that, and because I kept my decimals very, very accurate, it's almost a perfect fit. That's what that R squared value means. The closer it is to 1, the better the fit. So then I'm just going to round this right here, these numbers. So I'm going to make this 92.4 times 0.5 to the x. So this should be y equals 92.4 times 0.5, and then this is raised to the x. Alright, so there's my model. I'm going to type that into my y equals. So 92.4, and then times 0.5 raised to the x, and that should go through most of those dots pretty well. I rounded it a little bit, but it still looks like it's a pretty good fit. So then that would be my equation for that model. Alright, and so that's the end of the activity. So now you can go watch the video on the applications.